a question from January 13, question number 14 of Unit 1 Physics. So you guys would have drawn this question by now, I'm sure that. So let us have a quick discussion about how to answer this question. Okay. So first of all, first situation we are talking about the situation on the Earth. So let's draw a free body diagram. So the free body diagram will be weight is downward and the upthrust is, normal contact force is upward. So here we are going to apply the situation we studied, the lift. The person is accelerating on the lift or stationary on the lift. Since the person is stationary, the acceleration is zero. Acceleration is zero. Therefore, resultant force is zero. Since resultant force is zero, the upward normal contact force is equal to downward weight. So in this case, R equal to mg. R equal to mg because the resultant force is zero. Why resultant force is zero? There is no acceleration. Acceleration is zero because the person is stationary on the Earth. Okay, so this is the 3 marks and this is what you are going to answer. You can give an equation and you can explain when the person is on the Earth. There are 2 forces acting on the person. Weight acts downward on the person and the normal contact force acts upward on the person. Since the person is stationary, there is no resultant force. Therefore, the contact force from the flow upward equal to downward weight or weight. Okay, so this is the situation on the surface of the Earth. On the surface of the Earth, the person is stationary. So this will give you the 3 marks for you. And if you look here now, we are going to answer the next situation on the space. Okay, so here we are going to study what? Let's apply what we studied when the person is accelerating on the lift upwards. The person is accelerating upward means resultant force is upward. Resultant force is upward mean now the normal contact force is F equal to ma if you look. So what is F here? F is R minus W equal to ma. So R equal to W plus ma. Okay, R equal to mg plus ma. This is the situation when you are accelerating upward in a lift. Resultant force is upward. Therefore, the force in the direction of resultant force, that is the R. R is the normal contact force, is upward. So it has to be the larger force. So bigger force minus small force, R minus W is the resultant. So resultant equal to ma. So same situation we can apply. The person is on the space, he is accelerating upward. So we can apply the same situation here. But in this situation, since he is on the space, his G is 0. Since the G is 0, mg is 0. Therefore R equal to ma. So this is the next point. So in both situation, okay, both situation, the person's, the field, the normal contact force upward. In the Earth, it is R equal to mg, and on the space, R equal to ma. But the magnitude of the R in both situations is the same. Why? The acceleration is 9.81. On the Earth, R equal to mg, m into g, g is 9.81. On the space, R equal to ma, here A also 9.81. Therefore, he couldn't. So that's a 6 marks point. In both cases, the person feels the same force from the flow. Okay, so the person couldn't tell whether he was on the space, or he is stationary on the Earth. The reason, the force he feels from his feet is the normal contact force. The magnitude of the normal contact force is the same in both situations. Therefore, he couldn't distinguish that. Okay, so this is a 6 marks question from January 13.